Here is the code pen. Boop, 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 boop. And I'll put it in a string so we don't get a syntax error. So what we're going to do is turn this into a pipeline rather than introducing state and having an order of events. We're going to write last in stock. I'll leave this on the screen so we could look at it, but I have to rename it so it doesn't break. Whoops. And we'll say this is a function. We're going to compose it. Compose. And the first thing that happens in this whole thing, we take in cars and we call last on cars. All right, call last. Then we call prop with in stock. And then so last turns into reverse cars, and reverse cars goes in there. So we might as well just put this right there. There we go. So we're using currying. So it grabs the last, curries prop, and there you are. And you'll see this pattern a lot. If you see something like, f is x, and then, g on x, and then we have z is h on y. And so each of these arguments are just being kind of zigzagged, and you can just turn that into a composition. You can also take something like f of g of h, and, well, backwards, but f of g of h. And that's equivalent to the composition of f, g, and h. So it kind of unrolls this, this nesting, which is nice. Name of first car. So we're going to use compose, prop, and head to retrieve the name of the first car. So start with our compose, as we do. So we want the first car. So I guess we'll use head to get the first of the list of cars, because we're going to pass in cars here. We'll use head. From there, again, just like the last, we'll use prop, and I want to get the name. This is the data coming in. They all have a name. So we'll go ahead and just call name. And does that work? It works. Huzzah! If I do last or whatever, I'll get the wrong name, but it'll still work. So different name, same idea. Let's see, let's go on to exercise 3. Use the helper function average to refactor the average dollar value as a composition. Okay. Whew. This one's bizarre. It says to leave it be, but I so want to play with it. All right, so we're going to go with the average dollar value. It says we're going to grab c.dollar_value. Now I know this is just the prop function. We didn't really talk too much about the prop function. I probably should have introduced that. Let me just do that for completeness sake. If I say prop dollar value, that is the same as a function that takes some x and calls dollar value on it. In fact, it's the same. I think it's probably implemented this way where we call x dollar value. So these are all the same, right? Let's go ahead and change that then. So we'll do dot prop dollar value. And now we can start to see that cars goes into this thing, and we have that kind of zigzag pattern where this has got an output, and that output goes into this input. So why don't we rewrite this as a composition right below? We'll rename that, because const is the strongest thing in the world, right? It throws an error if I overwrite the thing. So we do that. We'll compose. And we just have to call average. Did it work? It worked. Hooray. Is this the same answer y'all got, or did you get a different answer? I'm seeing heads nodding. They're nodding left to right, actually. That's the wrong nod. No, I'm just kidding. They're nodding up and down for those online. So then we finally go to exercise 4. Let's see here. So this is our sanitization function. Replace anything that's not a word with underscore. Sanitize names, okay? And it says it wants us to write a function using compose that returns a list of lowercase and underscored names, which is this, but it needs to be lowercased. Interesting. Okay, so we're going to replace the things, but we also have to lowercase it. So let's start by composing. We'll start, and we're going to take in all the cars, right? So why don't we, and this is kind of a fun thing to do. Well, we'll do it like this. First, we'll map underscore. And then we're going to go ahead and map to lower. I don't know if I gave you this function. So that's fun. But it's in Ramda, and you could have made your own. So come on, it's built in. All right, so we're not passing yet. Let's see what's happening here. String replace is not a function.
You need the name.
So wait, I need what?
The name property.
Oh, thank you. So if we do dot map, thank you, prop. Look at these maps. This is ridiculous. We can do something that we'll learn later. Yeah, it works. Thank you for your help. So first we'll map all the names, then we'll underscore all of them, and then we'll lowercase all of them. Well, it turns out this map kind of distributes over the compose here. We can factor it out to the outside and get rid of all these nested loops and make it one composition on the inside. So map once. Oops, there we go. So that's kind of neat. That follows from a law on functors, which we'll talk about after lunch. But that's properties in action, right? Math in action, right there. Bam, bam. Should call this. And so that does the trick there. Any questions on this?
If we go back up to our, if we abstract the map out, we took the one map to 3.
Yes.
What is actually, like, how is that? Because this is obviously Ramda is doing the combinatorics to make that logic work.
Well, yes.
So, in rough sketch, how is 3 maps being turned into 1?
Yeah, I can actually kind of walk through what happens here and see if that opens up the, kind of clears up what exactly is happening. So they say this stuff isn't performant. Try to fuse 3 for loops. Oh yeah, I need to do it this as 2. Okay, and do I still? All right, cool. So now if I make this one 2 and that one 1, it still passes, right? We still get that happy green. A nice happy green. So what's happening with map? I think map is defined like this. It takes some x, some f and some x, and just calls x map f. It just delegates to the object. So if this is a list, it'll call map on the list. And we know because we're going to map over this entire. So we can take these maps off. Well, I guess have to curry it. But we'll use our own here. Get rid of theirs. And what's going to happen is we know that as we loop through this, we get an array of names. And then we loop through it again, and we get a list of underscores. We loop through it again. There's a property that states if I have a composition, map F and map G, that's always equal to mapping the composition of F and G. And so F becomes just this entire composition, and X gets hit with all of these functions each time in one loop, rather than looping and looping and looping. And there's these, map is coming from the category theory of mapping this category into that category, and we can talk a little bit about that. But because of the contract, the properties of map, this will always hold if you're writing functions. If you're not writing functions, anarchy. So there's that. Thank you. That was a fun thing to kind of discuss, which we'll see a little bit later, but I'm not going to get too much. This class is much more introductory, and I don't want to get mired in the math, just that you know it is there if you want it.